Hey y'all, I'm here to report on a brand new paper that just came out on the genetics of the last surviving woolly mammoths. It is an absolutely amazing study that reveals to us a lot of things about population bottlenecks, maybe the genetics of Noah and his family on the ark, and all sorts of other interesting things about the end game of small populations. So we're talking about genetic entropy and all sorts of other amazing things that come out from this new study by DeHask et al., Temporal Dynamics of Woolly Mammoth Genome Extension Prior to Extinction. They sequenced to a high coverage, not high compared to like modern good DNA, but for ancient DNA, maybe 5, 6, 7, 8-fold coverage, high coverage, 21 woolly mammoth genomes, spanning a time frame from a high mammoth population to a small mammoth population on a little island north of Siberia in the Arctic Ocean. It's called Wrangel Island. Oh, by the way, I'm Dr. Rob, and this is Biblical Genetics. And here on Biblical Genetics, we talk about all sorts of interesting things that tangentially or directly affect our understanding and appreciation of the biblical account of creation. But now we're just going to talk about woolly mammoths in a place where people don't usually associate with woolly mammoths. I'm on the island of Roatan, just off the north coast of Honduras. I can actually see the mountains of Honduras right over there on the southern horizon. Mammoths, however, range all throughout North and South America. I don't think they ever got to this particular island, but the mainland of Central America, South America, we got the Colombian mammoths, we got the woolly mammoths. They're probably the same thing, but people try to separate them. I've been on mammoth digs in Florida. I found 2 mammoth teeth, a baby one and a larger one in Peace River. I found a mammoth rib bone. I was on a dig once, an archaeological dig, where we excavated about 20 feet of dirt to reveal 2 mammoth skeletons lying basically on top of each other under the sand. Oh, that was so cool. But the woolly mammoth is extinct. How do we sequence their DNA? Well, they found mammoth bones on Wrangel Island. Now, Wrangel Island used to be connected to the mainland a long time ago. But on the evolutionary sense, 10,000 years ago was the height of the last ice age. And when the ice started to melt, the sea levels came up. And when it came up, Wrangel Island went from the Wrangel Peninsula to Wrangel Island. And it marooned some elephants, woolly mammoths or elephants, on this island. Now, in the biblical creationist model, this is going to be about 4,000 years ago, not 10 or 9,000 years ago. So we have the flood, we have the post-flood ice age, and 500 or 600, maybe 1,000 years later, as the ice is melting, the sea levels come up, and these mammoths got marooned. Using their carbon dates, they estimate about a 5,000-year time period when these mammoths survived on this island. Now, it's very important to understand how they're dating things. Go to creation.com and look up my article, How Carbon Dating Works. In that article, I provided a rough calibration curve where you can look at going back in time and age of something, and yet when you go back in time and look at the carbon age separates from the true age about 1,000 BC. And as you go further and further back in time, the two diverge. So I can take their carbon dates, and I can look at them and say, okay, they say 5,000-year span of this small population on the island, and I could just crunch that down into a shorter time period. That 5,000-year time period, they say, is 200 mammoth generations. Now, how do they get that? Well, they divide 5,000 by the average generation time of modern elephants, which is about 25 years, which is about 200 generations, therefore. But they actually didn't measure the number of generations. They just guessed based on their carbon date and the average range of modern elephants. But we don't know the generation time of woolly mammoths, just modern elephants. Also, when you're talking about an average generation time, elephants, they reach sexual maturity about 10 years old. And they might be sexually, they can have children until about the age of 40-ish. The average of 10 and 40 is right in that 25-year range. So they're using this average to make some of their genetic conclusions. We just have to keep that in mind as we look at some of their statistics. But it is absolutely fascinating because they had a large population of mammoths that went down to, they estimate, 8 individuals or fewer. That's the number of people that were on the ark, 8. So 8 or fewer mammoths survived on this island, and they grew to a population of 200 to 300, they're estimating. They ran what they say are extensive population modeling things. They tried this and that and this and that and that and that. And the best model they could come up with to fit the data was an effective size of 8 individuals or less, and they grew to 200 or 300 over the course of several generations. That's their model. That's the computer trying to fit the numbers to the other numbers, and that's what they came up with. Okay, so I can take that just as a rough estimate, but now we're talking about biblical population sizes, and what happened to that population? Did they go through mutational meltdown like I would have expected? Did genetic entropy take over? Did they start coming up with lots of birth defects and lots of inbreeding effects? That's a cool question, because that's going to directly reflect our understanding of the post-flood world and the animals surviving on Noah's flood and coming off and repopulating the world. They said something interesting. They said, the mammoth population on Wrangel Island has long been considered a textbook example of a population becoming extinct due to mutational meltdown. So people are surprised to learn that some mammoths survived until historical times. I mean, after the building of the Great Pyramids, there were still mammoths in Siberia and Alaska. And this relic mammoth population on Wrangel Island, which might be the last one surviving, I don't know, when God was parting the waters at the Exodus, were there still mammoths in Siberia? Quite possibly. I don't know exactly when they went extinct. I just know they're extinct now. We'll talk about why they went extinct in a minute, but let's just put that in your head, that these are historical animals, therefore we can sequence their DNA because they're not really that old. And we have multiple mammoths. This new study was 21 new mammoth genomes, and that's on top of the other ones they already had, the older ones they already had. So now we have a continuum of time. I don't think as much time as they think, but it's a continuum of time of all their DNA and their genetics. What they found was that after this bottleneck event, about 40% of the genetic diversity was lost. So a 40% reduction in heterozygosity. What's heterozygosity? Well, when you have 2 copies of each chromosome, if there's a place on a chromosome with an A and a G on the other chromosome, because you got an A for mom and G for dad, that's a heterozygous location. They showed a 40% loss in heterozygous letters. So they went from about, 0.75 per thousand, that's 7.5, that's about 75 variable positions in 100,000 letters, down to about 43 variable positions in any given 100,000 letters of the mammoth genome. So 40% loss. Okay, that's really cool. Would we expect that in humans after the flood? Yeah, absolutely. In fact, I've written a lot on bottlenecks on creation.com, and I've done a lot of bottleneck episodes here on biblical genetics. One of my earlier ones, like 4 years ago, was called Biblical Bottlenecks Are Not Bad. Because even though we went down to 8 people, the population expanded rapidly afterwards. And if you have a rapid expansion, you don't have a real bottleneck. You have a loss of diversity, but you don't have an accumulation of the bad mutations you see in small populations that stay small for a long time. The episode I did just after that was called Evolutionary Bottlenecks Are Disastrous, because the evolutionists they're claiming long-term bottlenecks, which would be really bad genetically. I did another episode a couple years later, Did We Evolve from 10,000 People in Africa? Again, talking about the African bottleneck, the pre-bottleneck before the supposed out of Africa event. I did one more recently, Evolutionists Predict a Super Bottleneck, and in parentheses, it would have killed us, where they're claiming that in order to explain the similarity of humans across the world, we needed a really big bottleneck, maybe 1,000 or so individuals for 100,000 years, 1,000,000 years ago in Africa. Oh man, just 1,000 individuals on effective size, was that 1,200 something, I think it was, 1,280 was that the number? That's a tiny little population. To last for 100,000 years and not go extinct? That's tricky, but maybe this elephant thing will help them out a little bit. We'll see. Over on creation.com, I've published a couple of articles in Journal of Creation. One was called, just on creation.com, Mutations and Why You Shouldn't Marry Your Cousin. Because, inbreeding is bad. But in the Journal of Creation, Effective Population Sizes and Loss of Diversity During the Flood Bottleneck. And then another Journal of Creation article, The Genetic Effects of a Population Bottleneck Associated with the Genesis Flood. Now, a lot of the information's already come out in my older episodes of the show, but that last one, The Genetic Effects of the Population Bottleneck Associated with the Genesis Flood, is directly applicable to this elephant question, or the woolly mammoth question. Because what I did was, I looked at modern populations and I said, okay, here's how much genetic diversity they have. I said, what would happen if you just picked 8 people out of that population? How much genetic diversity would you lose if you killed off all the rest of the population? Now, what if you picked a father and mother out of that population and give them 3 sons and then give them 3 random wives from random places in the population? In the random example, you lose about 24% of the genetic diversity. In the everyone's marrying their sister example, that's when you lose 43% of the genetic diversity. So the flood, guaranteed, there was a loss in human genetic diversity between 24% and 43%. That's called 20 to 40% loss of human genetic diversity just because of the population bottleneck, that very brief one-generation bottleneck associated with the flood. Okay? Very, very similar to this mammoth story, but they're using computer models to try to figure out the data where it could have been a lot less generations, a lot less time, and it still could have been 8 mammoths or fewer, they say. Interestingly, there's only 1 mitochondrial lineage amongst those mammals. So only 1 female line survived. Maybe 1 or 2 females amongst that 8-ish population, or maybe just 1, who knows. But they didn't have any Y chromosomes because they didn't have the technology yet to sequence Y chromosome. And I just learned that they have now looked at the Y chromosomes, but that happened after they published a paper. So we'll have to wait on that a little bit. Okay, now here's the really interesting stuff about what happened in this population. You would expect that the population is going to go extinct because of the accumulation of really bad mutations, right? Isn't that what creationists always say? That, bottlenecks short term are bad. That's what the evolutionists said too. I mean, we're learning from them. We're not making stuff up here. But what they showed was that over time in these elephants, the high impact mutations were purged. That is, the deformities, the broken genes, the things that have a big impact on the elephants were lost over time. I think because when you have a size of 200 to 300 individuals, you can afford to have individuals that are defective to die and not affect the absolute population size. If you had a lot less individuals, you can't afford to lose individuals because then your population would go extinct. But once you're big enough, maybe you can escape the effects of the accumulation of really bad mutations. Okay. I think Mendel's accountant also showed that, by the way. That's the whole thing. I just thought of that. I wonder. But what they showed was that the mild mutations accumulated over time. Oh, that's genetic entropy right there. The slow accumulation of these slightly deleterious mutations is what John Sanford has talked about, what Mendel's accountant has always showed. Yeah, you get a buildup of small mutations that are only slightly bad over time. And eventually those slightly bad mutations, which aren't profound enough for natural select to act upon, are going to overwhelm the population and they should go extinct. Well, is that what led them to extinction? I don't think so. What I think happened was that there was an environmental change. I mean, think about this. There are elephants living on Wrangel Island, where it's too cold for elephants to live today. There's not enough food. Elephant needs hundreds of pounds of food, weekly or maybe even daily. Maybe they need a lot of food to live. There must have been a lush grassland on that island, which does not exist today, which means that it was warmer back then. Because during the so-called last ice age, it was warmer than today. Siberia wasn't frozen over. It wasn't covered in mile thick glaciers. The glaciers are on Scandinavia. The glaciers are on Alaska. The glaciers were over central Canada. But Siberia had elephants and foxes and fruit trees and bunny rabbits and all sorts of other warm weather animals. And I think what happened was, as the world was cooling off after the flood, Wrangel Island maintained a warm-ish environment for several hundred years, and it finally froze over, and that's what killed the elephants. There's no evidence of human interaction here. It's not like humans killed them off. There's no evidence of human habitation on that island until later in time. That's really neat. I think it fits in the flood scenario beautifully. They said some a little more complicated but other interesting things. In demographically stable populations, the genomic effects of genetic drift and inbreeding are inseparable. What's genetic drift? That's the random changes of genes in small populations. So if you had a population of, let's say, 100 individuals, and 5 of them carried a really bad gene that caused something, defective, but none of them have it in 2 copies. So none of them actually die from it. It's just there, and it's potentially lethal. Well, in the next generation, one of those individuals might have no offspring. One of them might have 3 or 4 or 5 offspring. So random chance says that you can go from 5 copies to maybe 7 copies or 8 copies in the next generation, or you can go to 4 or 3 or 2 copies in the next generation. You get random fluctuations of gene frequency levels in small populations. That's called genetic drift. What they just said was that genetic drift is indistinguishable from inbreeding. That's everyone marrying their cousin or sister or some close related thing. Inbreeding drives down genetic diversity. When 2 people are closely related get married or animals mate together, their offspring have less genetic diversity because the 2 individuals aren't a fair sampling of the entire population. They're closely related. They only have a piece of the whole population's genetic diversity, and therefore, when you have individuals that are closely related inbreeding, you get a loss of genetic diversity, and it's indistinguishable in populations that remain the same size over time from genetic drift. But, they also said, drift and inbreeding have different genomic effects in declining populations. So populations that are getting smaller over time or that are getting worse over time, a drift and inbreeding will look different. So they tested those things, and they didn't see any evidence of a population decline, which I think they're defining as a dramatic increase of bad mutations. The elephants at the end had about the same number of bad mutations as the elephants in the beginning, but they did have slightly more moderate and lightly bad mutations. But they didn't see a catastrophic increase. Might be, though, that they didn't wait long enough. Maybe the elephants didn't live for 1,000 years, and that's when they would have gone through mutational meltdown. Or maybe they didn't find the last remaining mammoths. They're just grabbing mammoths from the mammoth tusks that are scattered about the island. They're carbon dating them. They're pulling the DNA out. Well, they don't know they got the last mammoths. Or maybe, just maybe, the small population is large enough to withstand the effects of mutational meltdown. Maybe you have to get 50 individuals, 25 individuals to truly go through mutational meltdown. But see, that's informing us about the post-flood world and the organisms spreading out on the ark, how fast they would have had to have grown into a larger population to resist going extinct. So it's the fast reproducing ones are going to survive. And as species or the created kinds are spreading out on the earth, they're getting separated. They're breaking up into smaller isolated populations. Well, each of those isolated populations had better grow fast, or they might go through mutational meltdown, or maybe if there's just a couple hundred of them, they can still survive. Very interesting. Now, I don't know all the answers. I'm just throwing out possibilities because it's just fun stuff to chew on. But one thing they did see, they saw a lot of deletions. A lot of places where they're just missing letters of the mammoth DNA. But they didn't see an increase in deletions over time. What they reasoned was that these deletions happened, or they're already in the population before the bottleneck, but the bottleneck fixed the deletions. Because if you have a missing piece of DNA, if that's changing in frequency over time, when it goes to 100%, well, that piece of DNA is lost forever. It's not in the population anymore. So you get a fixation of deletions, and that's maybe something we should be looking for when we're looking at the different created kinds and the various species derived from those created kinds. Maybe the mutations, the deletion mutations, will tell us separations between created kinds. I don't think that the creationists have looked at that yet. It's just a new thing for us to explore. Their conclusion: small populations may undergo purging of highly deleterious mutations, which could facilitate long-term persistence despite high levels of inbreeding. Very interesting. I think that actually might be something that saves us from the evolutionary retort, oh, you silly creationists, all these things would have inbred to extinction. Well, the woolly mammoths didn't inbreed to extinction. Looks like the climate killed them. So maybe our model's stronger than they think. Well, I think it's very strong, and I love this stuff, and it's fascinating, and it's interesting. But I think that's enough talking. That was 21 minutes recorded. Don't know how long it's going to edit. I'm going to try to get down to about 15 minutes. We'll see what I can chop out. Thank you for listening. Thank you for watching. I really appreciate all your support. My friends on patreon.com and buymecoffee.com. By the way, there are links in the show notes if you want to help support my channel. But this is my last day on this island. Came here to speak at a church. I had a couple of days, and now I'm going home, and there's a weather system blowing in. Even though we're kind of south of the main hurricane belt, we do get scattered remnants of stuff, and it's It's going to blow hard tonight, rain a lot. So I've got one more day for the water. Won't be much sun, but I'm going in. So have a wonderful, blessed, beautiful day no matter where you are. And remember, the Bible is true and Genesis is historical.